So let's do a little recap of what we know about similar polygons. So we know that two polygons are similar if one of two things are true, or actually if both things are true, right? The corresponding angles need to be what? That would be congruent, right? Corresponding angles must be congruent, and the corresponding side lengths, if they are similar, they need to be proportional. And just to go over a couple of other things, remember there's something called the similarity statement, which would be something like, I'm just using triangle for example, triangle ABC is similar to triangle DEF, let's say. And if this is a similarity statement, then we know that angle A is congruent to angle D, angle B congruent to E, and angle C congruent to angle F. We could then write what's called a statement of proportionality, and that's where we write each of the corresponding side lengths in their ratios, and we know that all the ratios have to be the same, which would be called the scale factor, right? So the statement of proportionality for this example would be AB is to DE, as BC is to EF, as AC is to DF. Right? Statement of proportionality, you would come up with a scale factor. If you were to reduce each of these fractions, you get what's called the scale factor. Okay? Just a little recap of what we talked about. Now this is with any similar polygons. So all different types of polygons that are similar to each other, not specific to any one kind. In this section, we're really just focusing on similar triangles. Okay? Similarity between triangles is very similar. Get it? It is very similar to congruence of triangles, where if you show a certain number of parts contain these relationships, then you know that the triangles are similar. Okay? So the first one we talk about really comes from the definition of similarity. Similarity means that the corresponding angles are congruent. So if the corresponding angles of two triangles are congruent, then the triangles are similar. And when we did our discovery of triangle congruence, we really did talk about this already. But let's just focus on the fact of, do we need all three? Okay, do we need all three of the corresponding angles to be congruent? And the answer is really no. We have something called the third angles theorem. And the third angles theorem states that if you know two angles of a triangle are congruent to two angles of another triangle, then you automatically know that the third angles are congruent. Right? And that has to do with the triangle sum theorem and things like that. So this idea of similar triangles is going to be a postulate, and that postulate is called the angle-angle similarity postulate, AA. You do not need the third angle. You only need two, because by the triangle sum theorem you can find that the third angles would be congruent as well. So copy this down in your notebook, and then we'll talk about it. So the angle-angle similarity postulate says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay? So here we can see in this example, we are told, here's our similarity statement, triangle JKL is similar to triangle XYZ. So we would know that angle J is congruent to angle X, and you could see that in the figure. Angle K is congruent to angle Y, and then we would be able to find that angle L is congruent to angle Z. That's my similarity statement, and from the similarity statement we could write the statement of proportionality. The statement of proportionality would say that JK is to XY as KL is to YZ, as JL is to XZ. Okay? And I just write that as many times as I possibly can to get you in the habit of seeing that statement of proportionality, because we will be using it to solve for missing side lengths of triangles. Okay? So let's look at an application of the angle-angle similarity postulate. This says, determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. So now we're not told that the triangles are similar, but we're trying to figure out if they are. Kind of like our triangle congruence, right? You have to figure out if they were congruent or not. Well, the same thing's happening with similarity. So if I look at the angle measures that I'm given, so in triangle CDE, I have a right triangle, and one of the angles is 26 degrees. Well, just by the looks of it to the other triangle, I have this angle of 64 degrees. Here, right away, I would say angle-angle is not true. But using the triangle sum theorem, I could find that my missing angle right here is 64 degrees, and this missing angle is 26 degrees. Therefore, these triangles are similar by angle-angle similarity, and this is a similarity postulate, I should say, right? And we could come up with a similarity statement. So triangle A, nope, not an A. I'm so used to saying ABC, but this is actually CDE. So triangle CDE is similar to, now angle C is 26 degrees, so that's congruent to angle K. D matches with G, and E here matches with angle H. So there's your similarity statement. And again, we could write our statement of proportionality. Statement of proportionality would be CD over KG equals DE over GH, which is also equal to CE over KH. Right? All right. That's angle-angle similarity of triangles. Fun stuff.